So this is a digression lecture. This is not a part of your curriculum, so this is not going to be a part of your exams. But this is just like additional information for your knowledge. So let's just revisit that error. The error that we actually saw when we were trying to compile this particular program of quadratic equations. Um, we saw something like this, right? I mean, this is before we actually gave it the minus lm switch. So what exactly is this error, right? So there is already a hint out there that there is something called as an ld, and this has returned some exit status. Okay, it says returned one exit status. Now remember that during the end of that particular program that we saw, I told you that just ignore what is return 0 for now. So exactly, 0 is basically what this particular program returns. Okay, so it is the exit status of your program. So whenever a particular program is executed, at the end this program actually returns a particular number, a particular exit status. 0 means that the program actually completed normally, successfully. Any other number, any number other than 0 means that there is some kind of problem. Okay, the program exited with some particular status. So what developers usually do is that they use this exit status value as a value to indicate certain types of errors. Now um, you might have actually seen these kind of errors at many locations, that the program exited with exit code something or exit status something. The idea is something like this, that you actually use these exit codes to define certain types of exceptional errors, or something that should not have happened. So anyhow, what exactly was that LD? So LD is actually a linker. Okay, linker is something that GCC uses in order to link different object codes into one executable. So what exactly is object code? Object code is basically machine dependent code that can be executed. So if we go back to our initial examples, for now just assume that object code looks very similar to that code. Okay, the code that we saw in the beginning, add, load, store kind of code. So this is basically a code that your machine can directly execute. It depends on your processor architecture, but basically some kind of code. For now, just assume that this is machine dependent code. Object code is machine dependent code, and what happens is that whenever you run something like GCC, it actually produces some object code. This is executed by your machine. Now that so-called -lm argument that we had provided was not really meant for the compiler, though it was meant for the linker. So -l was actually a switch, and m stood for math library. This was basically the library that defined sqrt. Remember the math.h header file that we included? That was just a kind of template, right? Template as in it only meant that there will be a function called sqrt that will be available from somewhere, okay, when this program will be executed. The math.h header file did not actually include the code for sqrt. So where was it? It was in the math library. And what we did was this was with this so-called -lm switch. At the time of linking, uh, this math library got linked with your quadratic equation code, and the final executable had definition for sqrt. Now there was a term called build. There was some of you who were a bit confused with what exactly does the term build mean. So now this is what build means, that you basically collect object codes from different sources, and then you put them together into one executable program. Okay, so this is what the linker does. Okay, it brings together codes from different sources, and then it produces one executable out of it. So how does linkers differ from compilers? So what exactly did we do when we invoked GCC in the background? There were two distinct steps that took place. In fact, there is probably a switch, I think minus C or something. So if you give GCC the minus C switch, it will only compile your code, and it will not link it, right? So it will not be an executable code. It will be just some machine code. So anyhow, so the first part of the program, first part of that step is that your program gets compiled into some kind of object code, and this is done by the compiler. Now, we already know that compiler is a software tool that understands a particular programming language. So, for example, there is a compiler for C, there is a compiler for C++. All the languages have their own compilers, and what it does is that it simply translates whatever you have written in, for example, a language like C, into something that is more understandable by your machine. So, we are calling that thing as object code. So compiler's job is to produce object code from the source code. So whatever you write in that .c file, compiler simply compiles that. And now uh, in general, right? So for example, I told you that at least two library functions that you will probably be using would be printf and scanf, right? Just to take inputs and output. So almost all the programs that you will write will require some additional code, some code that you have not written. It is someone else's code. So where do you get that someone else's code? This is where your linker gets involved. Okay, so this is the second stage of that two-step process. So what happens is, a linker is a tool that puts together object codes from various sources. So basically what happens is, at this particular step, you will have to tell the linker that printf is from this particular library, sqrt is from this particular library, and please uh, take object codes from different sources and produce one executable. Now, just to give you an idea, uh, printf gets loaded automatically because the library that has printf gets loaded automatically. It is a part of the standard C library, but math.h, the math library, is not automatically loaded. So that is why you needed that minus lm switch. Now, even in the linking, right, there are two types of linking. The linker can actually behave in two different ways based on its configuration parameters. So whatever we saw till now is an example of static linking. So what happens with static linking is that the linker basically finds out where are the sources of the of the code that you actually want to put inside your executable. So in this case, this code was basically the code for the sqrt function, and then what linker simply does is that it actually copies the code from that particular source into your executable. So if you see the final executable, you would basically feel that it was you who wrote the sqrt function, because the code for sqrt function has been copied from the math library to your executable. Now, in dynamic linking, the linker actually doesn't copy the code from that particular library. What it basically does, it actually adds certain amount of information in the executable about where exactly will this code be available when the program is executed, right? Because you only need the sqrt function when you execute your program, not really when you are creating the executable. So basically what happens is, in this particular case, your library is loaded by the operating system when the program is to be executed, and the advantage of dynamic linking is that your executable is much smaller, right? Because you are not copying code from other libraries. So now there is like one more term that I added. So this is loading, right? So now there is another component that gets involved in the process of executing a program, and that is the loader. Okay, so the job of a loader is to load an executable into the main memory. So now you remember that the executable 2 can now be of two types. There could be one executable which is basically a fat executable, where you have all the codes that are necessary to run this executable, which was basically baked by linker into the executable. This is, the case of static linking. Or it could be a case where basically the actual executable is small, and now at the time of loading your program, at the time of executing your program, the loader is the component that actually loads additional libraries into the main memory. So overall what the loader does is that it knows that there is a place on your disk where your program is lying. It copies the program from your disk into your main memory. Remember, in order to execute a program, you need it to be in the main memory. So then it uses this information stored in the executable. For example, if it requires any dynamic libraries, then what it will do is it will load those libraries to inside the main memory. Sometimes what happens is that these libraries are actually shared by multiple executables. So basically there is a smart way of loading these libraries into your program space. Anyhow, so let's not go into into that direction. So essentially it basically loads the library at some appropriate locations so that it becomes accessible to your program's code. And the loader is actually a part of your operating system. Okay, so in this case it would be part of your Linux operating system. And this is why the executables that you prepare with the help of GCC, they are actually platform dependent, right? Because the loader for Linux will be different from, let us say, the loader for Windows. So the a.out that you produced, that cannot actually be executed on Windows, right? So this was a very short lecture. It is basically a digression lecture. We'll have a couple more digression lectures in this course. There is some more reading material that I have given. If you want, you can go and have a look at it. Otherwise, this is not really a part of your curriculum, so it's not really necessary to go through this. Okay, thank you. Bye.